SpaceX's Fram 2 mission is expected to wrap up with a splashdown off the coast of California at any moment. You're seeing it landing from the sky.
Fram 2 just landed, but it's not the touchdown that's leaving everyone stunned. It's the strange experiments they conducted in space, the kind that could make even the most seasoned scientists gasp. From mushrooms behaving in ways that defy logic to bizarre, shocking phenomena, what they saw up there will send shockwaves through the scientific community. The crypto billionaire. The Fram 2 mission is one of those space stories that feels like something out of a movie, except it's very real, and it all started with a billionaire's dream. Chun Wang, a Chinese-born crypto mogul now based in Malta, made his fortune in Bitcoin mining. But instead of yachts or private islands, he set his sights on something much bigger: space. Using his own funds, Wang launched Fram 2, a mission that combined his love for adventure with a deep respect for history. The name Fram 2 comes from the original Fram, a famous Norwegian ship that explored the Arctic and Antarctic back in the early 1900s. The word Fram means forward in Norwegian, which fits perfectly with the mission's goal, to push the limits of human space travel and scientific discovery. Wang wanted to capture the same spirit of exploration, but this time in Earth's orbit. The crew was made up of 4 civilians, each bringing something unique to the mission. Chun Wang took on the role of mission commander. He's not just a businessman, he's a licensed pilot with a real fascination for polar regions. Jannicke Mikkelsen, a Norwegian cinematographer, served as vehicle commander. Her job was to capture the mission's best moments on camera. Rabea Roga, a German robotics expert and Arctic researcher, took the pilot role. She even ran amateur radio transmissions during the trip. Rounding out the team was Eric Phillips, an Australian polar guide who served as mission specialist and medical officer. He brought real-world experience from countless Arctic and Antarctic expeditions. Together, these 4 pioneers didn't just break records, they experienced Earth in a way no one else ever had. But it wasn't just about the views or the orbit, because somewhere between the North and South Poles, as they soared above the clouds and ice, the Fram 2 crew discovered something that no one saw coming. Training for the unknown. Fram 2 was first announced in August 2024. It was supposed to launch later that year, but ended up being pushed to early 2025. Unlike many space missions that go to the International Space Station, Fram 2 was a free-flight mission. That means the spacecraft would fly on its own, orbiting Earth without docking anywhere. What really made it unique was its flight path, a polar orbit that would take it directly over the North and South Poles. No crewed mission had ever done that before. The spacecraft used was SpaceX's Crew Dragon, specifically the capsule called Resilience, or Big Viewing Window, so the crew could see Earth's poles like never before. Before the Fram 2 crew ever stepped foot inside the spacecraft, months of careful planning, training, and last-minute checks were already underway. This mission wasn't just another space launch. It was the first time a crewed spacecraft would orbit over both the North and South Poles. That kind of history-making flight takes serious preparation, and every detail had to be perfect. It all officially kicked off in August 2024, when the 4 civilian astronauts were announced to the world. Right after that, the mission's science goals were set. Together with SpaceX, the crew began working on 22 experiments, most of them focused on human health and biology in microgravity. They wanted to find out how our bodies react in space, especially during such a unique orbit. Fast forward to mid-February 2025, and the crew made their way to NASA's Kennedy Space Center in Florida. There, they visited the Launch Complex, one of the most famous launch pads in space history. This visit wasn't just for photo ops, it helped the crew get familiar with the site, the equipment, and how everything would go down on launch day. By March 2025, the countdown had truly begun. The crew flew to Florida about a week before their scheduled liftoff. But before they could launch, they had to enter quarantine. This step was critical to make sure they didn't carry any illnesses into space. Then came 30th March, when they suited up and practiced every step of launch day during a full dress rehearsal. That same day, SpaceX fired up the Falcon 9 rocket's engines for a test. The booster passed with flying colors. Everything was nearly ready. Still, there was one more hurdle: the weather. The 45th Weather Squadron gave a 60% chance of good conditions, but there were worries about thunderstorms offshore. This mission was especially tricky, not just because of the polar route, but because it wasn't going to dock with the ISS. It would orbit completely on its own, which meant the weather had to be just right, not only at launch, but along the entire flight path and recovery zones too. The night everything changed. 31st March, 2025. Just before 10 at night in Florida, the skies were clear, the countdown clock hit 0, and Fram 2 soared into space. It was 10 o'clock Eastern Time when the rocket lifted off from the launch complex at the Kennedy Space Center. But no one was joking around. This wasn't just another space mission. It was history in the making, and Fram 2 became the first crewed mission ever to fly on a booster that had already launched 5 times before. That might sound risky, but it's actually proof of just how reliable SpaceX's reusable rocket tech has become. They've turned science fiction into routine engineering. Once in space, Fram 2 entered what's called low Earth orbit, but not just any orbit. Its highest point was 310 miles above the Earth, and its lowest was about 186 miles. More importantly, it flew on a polar path with a 90-degree tilt, which means it traveled over both the North and South Poles. That might not sound wild at first, but no human spacecraft had ever done it. The last time anyone got even close was way back in 1963, when the Soviet Vostok 6 mission reached 65 degrees. Fram 2 shattered that record, and there was more. After pushing resilience into space, the booster didn't just crash into the sea. It turned around and gently landed on a floating drone ship called a Shortfall of Gravitas, stationed in the Atlantic Ocean. Smooth, controlled, and spot on, even after 6 flights. Everything was going according to plan. Life aboard the space station. So, what exactly did the Fram 2 crew do once they made it to space? Turns out, quite a lot. Over the course of about 3.5 days, they circled the Earth 55 times. And because of their rare polar orbit, they flew over the North and South Poles every 46 minutes. That's right. Every single orbit took them across icy extremes, giving them a view most astronauts never get to see. But they weren't just up there for the scenery. This was a science-packed mission. The crew carried out 22 different experiments, with contributions from 8 countries. Each one had a clear goal: to help us better understand what space does to the human body and how we can survive longer missions, like a trip to Mars. Let's break down some of the standout experiments. One of the quirkiest and most talked about was called Mushroom. It was the first attempt to grow oyster mushrooms in space. Why mushrooms? They're a high-protein, low-resource food. If it worked, this could change how we think about feeding astronauts on long trips. Then there was something pretty groundbreaking, literally. Eric Phillips performed the first-ever X-ray in space, checking on bone density loss in zero gravity. That's a huge deal because astronauts lose bone mass in space, and we need to understand how to prevent it before going to Mars. Another important study focused on women's health. Using a special app and hormone tests, the crew looked at how microgravity affects reproductive hormones, an area that's been seriously understudied until now. They also wore Oura rings to track sleep patterns, monitored their blood sugar with continuous glucose monitors, and even contributed to brain imaging studies. After splashdown, a compact MRI device scanned their brains to see how microgravity changes brain structure, and it didn't stop there. They explored how space affects blood health, particularly anemia, and ran a yeast experiment designed by Dr. Corey Nislow to study how biology shifts in microgravity. All of it was fascinating. All of it was important. But it was what they saw outside the capsule on one of their passes over the South Pole that turned this mission into something far bigger than anyone expected. Shocking discovery. Unlike most space missions that orbit around the middle of the Earth, Fram-2's path was tilted at a full 90 degrees. They got a front-row seat to some of the planet's most untouched, mysterious, and beautiful regions. This kind of orbit is super rare for human missions. The International Space Station doesn't even go there. One of the stars of the mission was Jannicke Mikkelsen, a cinematographer who is no stranger to extreme places. She joined forces with a project called Solar Max, working with ground-based photographers at the University of Svalbard. Together, they captured synchronized shots of auroras, those amazing lights that dance in the sky. But they didn't just get the well-known green glows of the aurora borealis and aurora australis. They also chased something even rarer, a light phenomenon called Steve. Picture streaks of purple and green slicing across the sky like glowing ribbons. Steve is still a bit of a mystery, and catching it from both space and Earth at the same time? That was a first. Mikkelsen and the crew used everything from high-end cameras to iPhones to shoot through the Dragon capsule's cupola, a domed window with a 360-degree view. Chun Wang described seeing Antarctica from up there as looking down on a perfect, endless white sheet. Not a single human-made object is in sight. It surprised him. He expected to see something, anything. But it was just pure, untouched nature. On the other hand, the Arctic felt more personal, especially since the crew had trained in Svalbard before liftoff. That connection made the view feel almost like visiting an old friend. Lighting conditions weren't always in their favor, though. Since it was just after the vernal equinox, the South Pole was mostly dark, which made photographing it tricky. Still, the Arctic gave them plenty of dramatic shots. They even studied faint green fragments in the sky, subtle light effects that are usually missed by other orbits. Over their mission, the crew made 55 passes over the poles. They didn't waste a single one. The result? Stunning images, valuable data, and a better understanding of our planet's most remote regions. Even Eric Donovan, a leading expert on auroras, was thrilled with what they brought back, especially the rare views of Steve. This mission wasn't just a technical success. It was a passion project, dreamed up by people who love the poles and wanted to share them with the world. Splashdown. After more than 3 days in space, it was time for the Fram-2 crew to come home. But this wasn't just any splashdown. On 4th April, 2025, the Crew Dragon capsule Resilience gently hit the waters of the Pacific Ocean, just off the coast of Southern California. The mission was a success, but the world had no idea what was really coming next. This landing was special for a few reasons. It marked the first time SpaceX had ever done a crewed splashdown on the West Coast. Up until then, all their human missions had landed off the Florida coast. So why the switch? Simple: safety. By aiming for the Pacific, SpaceX made sure that the discarded trunk section of the capsule, the part that gets thrown away during re-entry, didn't fall anywhere near where people live. And speaking of re-entry, it was smooth. Once the deorbit burn was complete and the trunk section was jettisoned, Resilience began its fiery dive back through Earth's atmosphere. As it slowed down, parachutes opened and guided it gently to the ocean's surface. Now here's where things got even more interesting. The 4 crew members climbed out of the capsule all by themselves. No help needed. This was part of an important experiment to see if astronauts could exit their spacecraft without assistance. A crucial ability for future missions to the Moon or Mars, where rescue teams might not be an option. Rabea Roga was the first to step out, followed by Eric Phillips, Jannicke Mikkelsen, and finally Chun Wang. All 4 were wearing heavy 35-pound spacesuits, but they managed just fine. As they set foot on SpaceX's recovery ship, Shannon, they were met with loud cheers and wide smiles. The mood was electric. Once on board, the team got quick medical checkups and were then flown by helicopter to the California coast, where their families were waiting to welcome them back. Everything about the landing went as planned. And yet, what really shook people didn't happen during the descent. It was what the crew brought back. Not just data, not just personal stories, but something they saw during one of their polar orbits. The real struggles. Alright, let's get real for a second. Space might look beautiful from the pictures, but surviving up there? That's a whole different story. Every astronaut and every spacecraft that made it out alive deserves a standing ovation, because space isn't just tough, it's brutal. When Chun Wang and the Fram 2 crew entered orbit, the challenges hit fast. Chun admitted that every single crew member experienced space motion sickness within just a few hours. We're talking nausea, vomiting, and that strange disoriented feeling, not like regular motion sickness on Earth, but its meaner, more unpredictable space cousin. Yet even with all that, they didn't stop. They powered through. That alone says a lot about the mental and physical strength needed to be up there. Now let's talk about temperature swings. One minute you're being blasted by the sun with no atmosphere to soften the blow, and the next, you're suddenly plunged into freezing darkness. It's like going from a desert to the Arctic in seconds. These wild shifts put serious pressure on the spacecraft. Metal parts would expand and shrink over and over. If anything was even slightly flawed, it could warp or crack, and out there, no one's showing up with a wrench to fix it. Then there's the vacuum of space. No air, no pressure. Materials start to wear down fast. Some plastics or lubricants, they just disappear, literally evaporate. And moving parts like robotic arms or solar panels, those needed to be engineered to perfection just to keep from locking up. A tiny crack in a fuel line could have spelled disaster in seconds. Radiation was always waiting in the background, like a silent storm. Cosmic rays and solar flares were invisible but dangerous. They could mess up electronics, scramble data, or even wipe a computer's memory. Engineers had to think way ahead, building shields and backup systems that could keep things running even when space started throwing punches. And let's not forget space debris, little pieces of junk flying around at ridiculous speeds. Even a speck the size of a grain of sand could smash into a spacecraft like a bullet. Crews had to stay sharp, ready to dodge danger while juggling all their other tasks. Communication had its own problems. Signals could take minutes, sometimes longer, to reach Earth. If anything went wrong, the crew couldn't just wait around for someone on the ground to tell them what to do. They had to figure things out fast and hope the backup plans worked. And then there's the biggest change of all, zero gravity. Nothing works the way it does on Earth. Fluids float. Tools drift. Cooling systems need to be reimagined. Even basic human movement becomes a challenge. Everything, absolutely everything, has to be redesigned for a world where gravity just doesn't exist. The world reacts. Astronaut Chun Wang became a fan favorite when he posted from orbit, waving to Svalbard, the remote Arctic island where the crew had trained. That sparked a wave of photos from people around the world, snapping their own skies in sync with the Solar Max project. From Norway to New Zealand, the skies were lit, and the internet was too. One of the most interactive parts of the mission was Fram 2 Ham, a clever ham radio contest that turned scrambled images from space into a guessing game. Kids, teachers, and amateur radio fans jumped in, trying to match those distorted photos to real polar landmarks. Online forums buzzed with people talking about icebergs and geography like it was the next big TV show. For many, it made space feel not just cool, but close. Governments where the crew hailed from were glowing with pride. Malta celebrated Chun Wang's leadership, calling it a bold step in private space exploration. Norway leaned into their polar roots, thrilled that Jannicke Mikkelsen played such a big role, especially with the nod to the original Fram ship that once explored the icy north. Germany highlighted Rabea Roge as a symbol of progress for women in robotics, and Australia praised Eric Phillips, a polar expert whose skills helped bring the mission to life. Even Canada joined the celebration, with scientists like Eric Donovan calling the Aurora data priceless. Not everyone was on board with the excitement, though. A few critics raised eyebrows at the launch path and questioned whether private space missions like this were more about the show than science. But even they had to admit, Fram 2 got people talking. And not just about rockets, about Earth, its beauty, and what we still don't know. And of course, Elon Musk couldn't stay quiet. He cheered the mission online, calling the polar orbit a first for humanity, and joking that the poles look cooler from space than anywhere else. He highlighted the Crew Dragon's performance and shared fan photos of auroras. Musk didn't go deep into science, but he pitched Fram 2 as proof that private space travel is real, exciting, and maybe even the first step toward Mars. Whether you saw it as a scientific milestone or a social media event, Fram 2 did one thing for sure. It made people care about space again. Controversies and rumors. The Fram 2 mission wasn't just a space exploration event, it sparked a whirlwind of theories and controversies that got people talking. While the crew's breathtaking images of ice caps and auroras made headlines worldwide, some wondered if there was more to the mission than met the eye. One of the main theories that swirled around the internet was that Fram 2 wasn't solely about advancing science or exploring the unknown. Some skeptics believe the mission was more of a publicity stunt designed to promote private space tourism. Why? Well, the crew's makeup raised a few eyebrows. It wasn't just scientists and astronauts aboard. Instead, it featured a cryptocurrency entrepreneur, a cinematographer, a robotics expert, and a polar explorer. Social media users pointed out that these individuals, though talented, seemed chosen for their wide-ranging appeal rather than their expertise in cutting-edge scientific research. As the mission gained momentum, another controversy took shape: the safety and geopolitical implications of the polar orbit. Fram 2's launch from Florida, aimed at reaching a 90-degree polar orbit, passed over or near countries like Cuba and Panama. Some international observers speculated that this path could be seen as provocative, especially by nations sensitive to foreign overflights. Despite SpaceX and the crew reassuring the public that the flight path was carefully planned to avoid populated areas, critics raised concerns about private missions lacking the oversight that government-led space programs typically receive. This sparked a debate on whether commercial space flights should face stricter international regulations, particularly when it came to things like airspace and safety. Some argued that Fram 2 might be testing the waters for future private missions, potentially opening up new orbital routes for profit rather than just scientific exploration. The mission's funding also stirred the pot. Chun Wang, the Maltese cryptocurrency mogul who funded Fram 2, became a focal point for speculation. Some skeptics suggested that the mission was a way to promote Wang's business ventures or even test blockchain technology in space, though no solid evidence supported these claims. Others questioned if Wang's wealth and the mission's high-profile nature were designed to overshadow the scientific aspects of the mission. The lack of transparency regarding the mission's budget only fueled these doubts, with some wondering if the money could have been better spent on more Earth-based research. On the science front, there was a mild debate among experts. While some, like aerospace researcher Christopher Combs, argued that the polar orbit was more about flexing SpaceX's capabilities than making a real scientific impact, others disagreed. Eric Donovan, an Aurora scientist, defended the mission, saying that the unique polar orbit allowed for valuable human observations that couldn't be matched by satellites. Still, some scientists questioned whether the mission overhyped its research value, given the risks associated with high radiation areas at the poles. What happens next? While many missions in space focus on Earth, polar orbits are crucial for future exploration beyond our planet. One of the standout experiments was the Mushroom Project, which tested the growth of fungi in space. Why fungi? Well, fungi are a resilient, low-maintenance food source, making them perfect for future space missions where resources will be limited. The idea is that we could see fungi integrated with plants, or even genetically engineered to produce higher yields, helping support future lunar or Martian colonies. But that's not all. Health experiments were also a major part of the mission. These kinds of advancements will be crucial for long-term missions where resupplying from Earth won't be possible, ensuring that astronauts can stay healthy in alien environments. The polar orbit itself also offered valuable scientific insights. Observing the auroras and studying radiation levels in this region of space gave scientists a new perspective on both Earth and space. The mission may have been a small step in the timeline of human space exploration, but its potential for future missions is limitless. We hope you enjoyed this video. Stay tuned for more.